All right, good morning, everybody. Today we are going to learn how to solve power and radical equations. And so we would call this a power equation because there's an equal sign and we have a power. And then we'll solve radical equations. That would be when you have a square root or cubed root or fourth root. And basically, we're not simplifying. We're trying to find the answer or answers that make this true. And sometimes there's nothing that makes this equation true. So how do you solve a power equation? These are power equations. You get the exponent, you isolate the exponent and power. This one's already isolated. This one is not. I need to get rid of the 3. And then you take the nth root. If it's raised to the second, you take the square root. Raised to the second, you take the square root. And then you should always check your answers because sometimes you get extraneous solutions. So the first one, and I could kind of do this one in my head, but just kind of keep in mind that to the second power, there's 2 solutions. We talked about that. They could be the same. But I already can see this and see one answer is 5 because 5 plus 3 is 8. 8 squared is 64. So let's go ahead and solve because the other one's not as easy to see. So I isolated the exponent. I take the square root of both sides. Now, anytime you take the square root, so the square root cancels out the square. But anytime you take the square root, you should do the positive and the negative. Okay. Now the square root of 64, that's 8. Solve for x. So I'm going to subtract 3 from both sides. And I get x is positive and negative 8 minus 3. So my 2 solutions would be positive 8 minus 3. Positive 8 minus 3 is 5. So one solution is 5. The other solution would be negative 8 minus 3. And negative 8 minus 3, that's negative 11. Now I already know 5 works. I had that from the beginning. Let's just double check negative 11. Negative 11 plus 3 is negative 8. If you square negative 8 times negative 8 is positive 64. So I'm done. Now we already solved these in our quadratic unit. This is what we call vertex form. The vertex is negative 3, negative 64. That's the bottom of the parabola or the top. And so both of these problems should look pretty familiar. All right, on this problem, isolate the exponent. So I'm going to divide both sides by 3. And I get x minus 5 squared. And negative 27 divided by 3 is negative 9. Well, we have a problem. And the problem is, I notice it, but you may not notice it till the next step. You cannot square a number and get a negative back unless you're dealing with the imaginary number system, which we're not going to mess with. So technically, there are 2 solutions. They're imaginary. But for now, I just want you to put no real solution. So if we're solving this, we would take the nth root. It's a 2, so we're going to take the square root of both sides. Positive and negative. But you should recognize that anytime you have an even root and a negative number, that should be no real solution. you may be thinking, why not just find the imaginary solutions? And technically we could, but I feel like this is enough by itself. We've already learned how to do that, and I just want you to go back to no real solution. Now, whenever you solve by square rooting a number, you must always put the positive and negative in front of it. And that's actually true for all even roots, 4th root, 6th root, 8th root, 10th root, but not true for odds. Okay, and we'll talk about why. So like -2 to the 3rd, that's -2 times -2 times -2, that's -8. But 2 to the 3rd, 2 times 2 times 2 is 8. Notice they are not the same thing. However, when you square, -2 squared is 4, and 2 squared is 4. So anytime you have an even root, you get the same number. That's why you have to look at the positive and the negative. With an odd root, they're unique, so you don't have to do positive and negative. Okay. So then what number to the 3rd is 8? That would be just 2. Because I would take the cube root of both sides. Cube root of that and cube root of that. And I don't have to put positive and negative. And what's the cube root of 8? That's 2. Here, take the cube root of both sides. I get x equals the cube root of -8, which would be -2. Here, take the square root of both sides. But I must put positive and negative, but you can't take the square root of a negative number, so you put no real solution. And then here, what number squared equals 8? I take the square root of both sides. Positive and negative. Positive and negative, square root of 8. Which technically I could simplify that. That'd be what? 2 and 4, 2 and 2, 1 pair of 2s. So 1, 2 comes out, so it'll be positive -2 square root of 2. So there's 2 things that make it true. And the reason why there's 2 things that make it true is because when you square something, it always makes it positive. So there's 2 ways to get positive 8. Okay. Here, we may not go through all the examples, but I would divide both sides by 2. That'd be 81. And then to undo the 4th power, I take the 4th root. And I have to do positive and negative. Anytime you're trying to get the exponent by itself and it's even, you have to do positive and negative. And trying to remember what 4th root of 81 is. 3 times 3 is 9, times 3 is 27, times, I think it's 3. Pretty sure it's 3. Let me see, 3 to the 4th power. Yes, that's 81. So this would be positive and -3. Check our work. 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 3 is 81, and 81 times 2 is 162. So positive 3 works. -3 to the 4th is also positive 81, and 81 times 2 is 162. So there's my 2 answers. Nothing is extraneous. Here I'm going to take, I have the power by itself. There's no way to get rid of a -2 because it's with the x. If there was a number out here, I would divide by it. If there was a plus out here, I would subtract it. But to undo the power of 3, I take the cube root. And because cubed is odd, you do not do positive and negative. All right. Now the cubed root of negative 125, 5 times 5 is 25, times 5 is 125. So I guess I would need negative 5. Negative 5 times negative 5 is 25, times negative 5 is negative 125. So this is negative 5. I would then add 2 to both sides. And I get x equals negative 3. Okay. Negative 3 minus 2 is negative 5. Negative 5 to the third is negative 125. There we go. Now, in case you're wondering, wait a minute, you said anything to the third power had 3 solutions and only wrote down 1. It's because I'm guessing the other 2 are imaginary. So if I were to solve this, if I was to get this by itself, and I'll show you. I moved everything to one side, and I'll go to Desmos and show you what it looks like. And this is another way to find the solution, but not a way I will take. Oh, I see what I did. Yeah. We can see the only solution it has is that negative 3, which is what I have. The other 2 must be imaginary. Okay. So this is one way to check your work. Or if you don't want to move everything to one side, technically you could put x minus 2 cubed on one side, negative 125 on the other. But then you got to go like way down here and see where they intersect. I'm not sure I recommend this way. Yeah, I wouldn't do it that way. I would just type it in. All right. So on this page, we have many, many, many more power equations. There's really nothing unique here. I don't have time for every example, but we could do this one real fast. So I have 2x cubed equals x cubed plus 54. Notice these are like terms. So what I'm going to do is I'm going to subtract x cubed from both sides. And 2x cubed minus 1x cubed is 1x cubed. So I get x cubed with a 1, you don't have to put a 1, equals 54. I then take the cubed root of both sides. So I get x equals, and I almost put positive negative, but it's odd, so you don't need that. So it'd be the cubed root of 54. See, my brain is not on yet this morning. Cubed root of 54. Type in your calculator. 3.779. We are learning about radicals right now, so you should reduce that. Let's go ahead and reduce it. 54. Let's see, we're trying to reduce that. That's 2 times 27. 3 times 9. And 3 times 3. Looking for pairs, I have one pair. I have a 2, 3, 2 3s. Oh, I almost messed up. This is cubed root of 54. I'm looking for 3 3s. Here we go. Here's my 3 3s. So there's 3 3s, 1 3 comes out, and then the 2 stays inside. So what looks better than this, more simplified, would be x equals 3 cube root of 2. And since it is Monday morning, I just want to type that in my calculator real fast. And I did. I typed in 3 times the cube root of 2. Notice those are the same decimal, so I feel good. Okay. I'm always checking my own work. On this problem, you would need to add 3 to both sides and then take the 5th root. There's really nothing unique there, but I do need to make sure we move on. Basically a whole page of the same thing over and over and over. How to solve radical equations. Notice the radical because we start off with the square root. We're going to isolate the radical on one side of the equation. Notice radical is already isolated here. Not isolated, I need to get rid of -9. Here, not isolated, I need to get rid of +6. Here, there's no way to isolate it, but when you have a square root equal to a square root, it's pretty easy. We're going to raise each side of the equation, not each term, to the power that would eliminate the radical. You will be left with the linear, quadratic, or other polynomial equation to solve, and then you solve it. Check your solutions. There may be extraneous solutions. So already simplified, I just square both sides. I'm sorry, already simplified, already isolated, square root is. The square cancels out the square root. So I get 2x plus 4. 8 squared is 64. This left me with a linear equation. These are easy. Solving, I subtract 4 from both sides. I get 2x is equal to 60. Divide both sides by 2. And I get x is 30. Double check our work. 2 times 30 is 60. 60 plus 4 is 64. Square root of 64 is 8. We're good. Next, isolate the radical. Step 1. It's not isolated. We need to get rid of +9. So I'm going to -9 from both sides. And I get square root of 6x plus 1 is equal to 16 minus 9, which is 7. And then you raise each side of the equation to the power that would eliminate the radical. This is the square root. So we're going to raise both sides to the second power. The square cancels out the square root, left with 6x plus 1. Seven squared is 49. We're left with another linear equation. I subtract 1 from both sides. I get 6x equals 48. Divide both sides by 6. And I get x is 48 divided by 6, 8. Done. Double check. 6 times 8 is 48, plus 1 is 49. Square root of 49 is 7. 7 plus 9 is 16. We're good. All right. This one, I need to isolate the radical. I'm going to subtract 6 from both sides. So now the radical is isolated. Step 2, raise each side of the equation to that power. So this is a square root. So I'm going to raise both sides to the second. The second cancels out the square root, leaving 2x over 3. 2 squared is 4. Again, this is almost the proportion. You could think of this as 4 over 1 and then cross multiply if you want. I'm probably just going to multiply both sides by 3. 3's cancel. 2x equals 12. Divide by 2, you get 6. Double check our work. 2 times 6 is 12. 12 divided by 3 is 4. Square root of 4 is 2. 2 plus 6 is 8. We're good. Now, when you have a radical on both sides, hopefully they're the same index. You're just going to raise both sides. I'm going to recopy this. They're actually pretty easy, I think. We're just going to square both sides. Whatever you do to one side, you have to do to the other. The square cancels out the square root. The square cancels out the square root. So now I get 5x minus 7 equals 3x plus 3. This is from Algebra 1, solving for x. I subtract 3x from both sides is one way. I like to go ahead and add 7 to both sides. Those cancel, those cancel. You get 5x minus 3x is 2x. 3 plus 7, 10. Divide by 2, you get 5. Checking my work, 5 times 5 is 25. 25 minus 7 is 18. That would be square root of 18. Square root of 18. See if I can remember that. 3 times 5 is 15. 15 plus 3, 18. Square root of 18. So 5 works. All right. So running out of time, so I'm going to pick and choose. Isolate the radical. So I'm going to add 2 to both sides. Two plus 2 is 4. Now this is where you have to be careful. We've been squaring every side, but we can't square both sides this time. We need to raise both sides to the third because the index is 3. The 3 and the cube root cancel. So I'm left with 5x minus 1 over here. And then 4 times 4 times 4 is not 12. Some kids put 4 times 3 and 12. 4 times 4, oh, too early for that. 4 to the third power is 64. I knew that. Add 1 to both sides to get x by itself. We get 5x is 65. Divide 65 by 5. That's 13. Check my work. 5 times 13. I will use a calculator. 5 times 13 minus 1 is 64. The cube root of 64 is 4. And 4 minus 2 is 2. So we're good. Checking your work doesn't take any time. You don't have to show me your work for checking your work, but I will say some of these have problems that end up with extraneous solutions. I'm going to show you one of these. These are actually probably the hardest radicals. I need to make sure I show these. The radicals isolated, so we square both sides. Now I square because it's index of 2, so I square both sides. The square cancels out the square root, so I'm left with 7x plus 5. But over here, I now have x plus 1 squared. Whoa. This is not x squared plus 1 squared. X plus 1 squared, that means write it down twice. You then distribute x times x squared. X times 1, 1x. 1 times x, 1x. That makes 2x. And 1 times 1, 1. In case I confused you real fast, did x with the 1, x with the 1, and you distribute, that's x times x is x squared, 1x, 1x. We have two 1x's making it 2x, and 1 times 1 is 1. Now remember, when you're solving for a quadratic, you want to keep the square term positive. So we're going to move over 7x and 5. Minus 7x, both sides. Minus 5, both sides. Remember, we always try to get 0 on one side because we can use the zero product property that we've already learned. So that'd be x squared minus 5x, and 1 minus 5 is negative 4. We have a quadratic. How do we solve those? You can use the quadratic formula. It takes a little bit. X equals negative b plus or minus square root b squared minus 4ac all over 2a. You could graph it and see where it crosses the x-axis. Or you could factor. I'm going to factor because I don't feel like jumping over to Desmos. So we're trying to find two numbers that multiply to negative 4 but add to negative 5. That would be negative 4 and negative. Ooh. I think I have those backwards. I know I don't have these backwards, but I don't think there is anything. Well, maybe I will go use Desmos. I'm going to type this into Desmos real fast. Because I don't think it factors anyway. X squared minus 5x minus 4. Ooh. Yeah, so those are my two answers, but we don't like decimals. So I guess I would have to use the quadratic formula to get the exact answer. It depends on what they're wanting. The decimals, these would be fine, but I'm going to guess they want the radicals. Usually they work out to something that factors, whole numbers. So then I'm just going to do it real fast, the quadratic formula. See, that's x equals negative b plus or minus square root. Been a while. So this is A. A is 1. B is negative 5. C is negative 4. So it'd be negative negative 5. That's 5. And then negative 5 squared, 25. And then negative 4 times 1 times negative 4, that'd be plus 16. And I'm kind of doing the work as I go. I'm almost out of time. And then 2 times 1 is 2. 25 plus 16 is 41. We get x equals 5 plus or minus square root of 41 over 2. And 41, I believe, is prime, so we can't reduce that. Okay. And then I'm just going to double check, what is 5 plus the square root of 41 divided by 2 as a decimal? That's 5.70. Yes. And then what's 5 minus square root of 41 as a decimal divided by 2? That's negative 0.701. Well, we round up, negative 0.702 on my calculator. And technically, I need to plug my answer in. There is an easy way on your calculator if you have one of these. I guess one way if we check our work is we could plug this on one side and that on the other. There's many different ways. So what I'm saying is put the left side on. That's the square root of 7x plus 15. The other one is x plus 1. Yeah, that's not going to work. Huh. Oh, dang, I see. So looking at this, both my answers are wrong. The answer should be 7. And I see my problem. I knew this problem was too hard. Oh boy. I know we're just slightly over. Just give me a minute. I see the issue now. This is a 15. I wrote it down as a 5. When I carried it down, I brought it down as a 5. So this is 15. So then that's 15. So then that's 15. And so then I subtract off 15. So then I subtract off 15. Usually we don't mess with decimals in a radical equation. So now 1 minus 15 is negative 14. Now this is negative 14. And I think it factors now. And so I don't need any of this. Sorry for wasting your time. So what multiplies to negative 14 but adds to negative 5? That'd be negative 7 and 2. I get 0 equals x minus 7, x plus 2. We use the zero product property, we get two answers, 7 and negative 2. Now, usually when you're dealing with the quadratic and you start with the radical, usually one of them is extraneous. So let's plug them in. And we already saw from the graph that 7 is the answer and negative 2 didn't work. So let me show you that negative 2 doesn't work. On the left side, square root of 7 times, and I think one answer is negative 2. Oops. I need to add 15 before I close it. And that is 1. But then when I plug in negative 2 on the other side, negative 2 plus 1 is negative 1. Those are not the same thing. So negative 2 is extraneous. So I need to say that this is extraneous. So the only solution is 7. And we had that when we were looking at here, we saw that the solution was at 7. Okay. Yeah, I normally don't do this, but I feel like we just need to finish this one. I'll do it really fast. Square both sides, and I'll copy it down correctly. You get 21x plus 1 equals x plus 5 squared. And I am going to kind of skip some steps for time. I copied it down correctly. Yes. Okay. 21x plus 1. And if you take x plus 5 times x plus 5, you get x squared plus 10x plus 25. You will then move everything to one side, minus 21x, minus 1. Bye-bye. You get 0, which is what you want in a quadratic. 10 minus 21, negative 11. 25 minus 1 is 24. Looking for two numbers that multiply to 24, but add to negative 11. Be negative 8, negative 3. So I get 0. It's x minus 8, x minus 3. Use a zero product property, I get 8 and 3. Okay. Then I check my work, either using Desmos or plugging in. I'll start with 8. So the square root of 21 times 8 plus 1, close the radical. That should equal 8 plus 5. 13 equals 13, yes, okay. So I plugged 8 in, 8's good. Now I'm gonna plug 3 in. Square root of 21 times 3 plus 1, close the radical. That should equal 3 plus 5. 8, they both work. So none of these are extraneous. Or go here, type in the left side, type in the right side, see where they intersect. They intersect twice. 1 is at 3, 1 is at 8. So if you have Desmos and you're trying to find the solutions, they're pretty easy with Desmos if you don't have to show work. But for the practice, I do ask that you show work. Anyway, I did go 5 minutes over, sorry. That's all I got. Have a nice day. Bye-bye.